Bismillahirrahmanirrahim. Assalamu alaikum students. Today we are starting our lecture number 2, which is from topic resolution of vector. Last time we have left last equations of these topics. Today we are starting from this. That is the topic wise. 4.3 resolution of forces. A little overview of that. The resolution of forces means the splitting of a force into its two mutually perpendicular components. Perpendicular components means the components which are at 90 degree to each other. In this topic we have considered a force F and resolve into its two perpendicular components. The component along x-axis is called horizontal component and it is represented by Fx. The component along y-axis is called vertical component and it is represented by Fy. OA line represents vector F, OB represents Fx and BA represents Fy. Now we draw an equation according to head to tail rule. OA is equals to OB plus B into A and OA is equals to F. OB is equals to Fx plus BA is equals to Fy. This is equation 4.2. Now we use the trigonometric ratios to find out the equations for the perpendicular components of a force. The trigonometric ratios, as we discussed earlier, that cos theta is equals to base divided by hypotenuse. In this triangle, base is Fx and hypotenuse is F. That's why we divide Fx divided by F is equals to cos theta. We have to find the value of Fx. That's why we multiply F to the other side of equation and we get equation 4.3. Now we use sin theta. Sin theta is equals to perpendicular, which is Fy, divided by hypotenuse, which is F. That's why Fy divided by F is equals to sin theta, and we get an equation to find out the vertical component of a force, which is called equation 4.4. Here we discuss an example. A man is pulling a trolley on a horizontal road with a force of 200 Newton. We have a force 200 Newton making an angle 30 degree with the road. Find the horizontal and vertical components of its force. Now we discuss in the last topic that Fx is equals to F cos theta. We put the value of force 200, cos remains same and theta is equals to 30 degree. Now we solve cos 30 is equals to 0.866 multiply by 200 and the vertical component, horizontal component of the force is 173.2 newtons. Now the vertical component of the force, we put the force F sin theta 30 and again we find the value of vertical component of a force. Here a mini exercise in a right angle triangle. Length of base is 4 cm and its perpendicular is 3 cm. Find length of hypotenuse. So students, to find the length of hypotenuse we use the formula, which is that hypotenuse square is equals to base square plus perpendicular square. Here base is given and perpendicular is given, you find, and last take the under root to find out the length of hypotenuse. Sin theta is equals to perpendicular divided by base, perpendicular is given, divided by hypotenuse. hypotenuse की लेंथ आप फाइंड कर लेंगे, देन इसको यहाँ से हम पुट करके फाइंड आउट कर सकते हैं इजीली. cos theta is equals to base divided by hypotenuse and tan theta is equals to perpendicular divided by base. Move to our next topic, which is determination of a force from its perpendicular components. Earlier we have discussed that we have divided a force into its perpendicular components and then we drive the equations to find out the magnitude of these perpendicular components. In this topic we have to find out the force F with the help of its perpendicular components. That's why we represent line OR with force F, OP with Fx and PR with Fy. According to head to tail rule, OR is equals to OP plus P into R because resultant OR is resultant vector and these are two its individual vectors. Now we put the values. OR is equals to F, OP is equals to Fx and PR is equals to Fy. The magnitude of the force can be determined using the right angle triangle in which hypotenuse square, which is OR, is equals to base square, which is OP, plus perpendicular square, which is PR. Now put the values. OR is equals to F whole square plus Fx whole square plus Fy whole square. We have to find out the force F, not its square, That's why we're taking under root on both sides of equation. Here under root is cancelled with square and the other side of equation remains with the under root. This is the equation to find out the magnitude of a force when you have its both horizontal and perpendicular components are given using by equation 4.5. Now if we have to find the theta between the two components of a force, then we'll use the third trigonometric ratio, which is tan theta is equals to perpendicular divided by base. We have perpendicular is equals to PR and base is equals to OP. Perpendicular is represented by vertical component of the force, which is Fy, and OP is represented by the horizontal component of the force, which is Fx. Now we have to find the only angle theta. That's why tan moves towards the other side of the equation and becomes tan inverse Fy over Fx. This is equation 4.6 to find out the angle between any two components of a force. That's it, boys. Dear students, if any question, then please send. I shall give you a reply. Thank you very much. Allah.